Energy meter with Modbus connection, is also referred to as the meter. Hello, my name is George, and I will guide you through this session on the SolarEdge energy meter with Modbus connection. In this session, you will be introduced to the terminology, product description and its applications. You will learn how to correctly install and configure the meter. In addition, we'll present two common troubleshooting examples. Let's start with some of the terminology that we'll be using throughout this session. Export and import electricity metering helps us determine the amount of electricity generated and used on our site. An export and import meter records how much energy we export to the grid or import from the grid. The SolarEdge inverter can either inject power to the grid or purchase power from the grid. An export-import meter is usually installed at the connection point to the grid. Consumption is the power consumed by the site. Consumption meter is a meter installed at the consumption point of the load. Self-consumption is the power produced by the PV and consumed by the site. Production is the PV power produced by the PV system. A production meter is a meter installed at the inverter output point. Product description. The meter is small, easy to install, and fits in a standard electrical panel, for supporting residential, commercial, and utility-size installations. It enables measuring the power and energy of the PV system, and is used by the inverter for different applications such as high-accuracy energy readings, in production and consumption monitoring, import and export meter readings, export limitation functionality, maximized self-consumption and smart energy on-grid applications. The meter supports both single-phase and three-phase grids, and requires the installation of current transformers. These CTs are also available from SolarEdge. Included in the meter packaging are the SolarEdge energy meter with Modbus connection, 2 DIN rail adapters, 4 screws, an installation guide. Metering applications. In order to get correct and accurate values for each meter application, it's very important to install the CT in the right location and direction, as well as configure the meter function accordingly. Let's take a closer look at this example. The CT is installed at the output power connection of the inverter, and the meter application is used for measuring production power or energy metering data, which is sent back to the inverter via the communication cable. Here we can see a CT, in grid connection, the meter application used for measuring export and import power to and from the entire location. Data is sent back to the inverter via the communication cable. Here we can see a CT connected to the loads, the meter only measuring consumption inside the location. Data is sent back to the inverter via the communication cable. Meter connection options. RS485 is used as a communication line between the meter and the inverter. In a single inverter system, the meter is connected directly to the RS485 port of the inverter. In a multiple inverter system, two options are available. In the first option, the meter is connected to an RS485 port of one of the inverters. If the inverter has a second RS485 port, use this port to connect between the inverters. If the inverter has only one RS485 port, use an RS485 plugin available from SolarEdge or Zigbee communication between the inverters. In the second option, the meter is connected to one of the RS485 ports of a commercial gateway. Meter interfaces. In the meter's interfaces there are voltage connections, for connection to the grid. CT connections L1 CT, L2 CT, L3 CT, for connection to current transformers. LEDs, used to monitor meter status. RS485, for connection to the inverter gateway. The three LEDs, on the front of the meter, indicate current status. During normal operation, the green LED will blink. The yellow LED provides status indication for the RS485 Modbus communication and blinks when communication with the inverter is OK. And a single blink from the third yellow LED indicates the meter reads an energy change of approximately 1 kWh. The Modbus address dip switches are used to set the Modbus address of the meter. The addressing options are listed in the table below. The termination dip switches are used to configure RS-485 wiring termination. The termination options are listed in the table below. Meter installation. Before installing the meter, let's review the meter installation guidelines. To select AC wires, use the following wire specifications. Use stranded wires in a diameter of 1.3 to 2 mm, designed for a minimum of 600 volts, type THHN, MTW, or THWN. To protect from overcurrent, connect circuit breakers or fuses on the wires connected to L1, L2, and L3 alternating current terminals. Make sure that circuit breakers or fuses cannot exceed 20 amps. To select RS-485 communication wires, use the following wiring specifications. Use a shielded twisted pair cable, with a minimum of 3 wires. A 4-wire cable may also be used. The cross-section area of the wire should be 0.2 to 1 square millimeter. A Cat5 cable can also be used. The meter installation consists of 3 steps. Mounting the meter, installing current transformers (CTs), and wiring the meter. And now, it's time to mount the meter. The meter can be mounted directly on a wall, or a DIN rail. The meter is supplied with 2 DIN rail adapters and 4 screws. To mount the meter on a DIN rail. 1. Attach the DIN rail adapters to the DIN rail. 2. Connect the meter to the DIN rail adapters, and fasten them using the supplied screws. To mount the meter directly on a surface. 1. Use a pencil, mark the drill positions on the surface, using the 4 mounting holes on the sides of the meter as a guide. 2. Use the supplied screws to mount the meter. Do not over-tighten the screws, as it may damage the brackets. Current transformers, or CTs, are devices that help measuring the alternating current flowing through the power lines. Before we begin, it is very important to place the CT in the correct direction. Incorrect orientation of the CT will cause wrong readings, and malfunctioning LED indication on the meter. Take a look at the figure, and make sure that you identify the arrow, shown on the CT. To connect a CT to a conductor. 1. Turn off alternating current power before clamping on current transformers. 2. Install the CTs around the conductor to be measured. 3. Install the CTs with the arrows pointing to the grid for consumption or export measurement. In this site we can see an overview of emitter connections to a 3-phase grid. On the left-hand side, we have a terminal block for connecting the AC wires, and on the right, we have the RS-485 communication connections to the inverter and 3 current transformers. And now, it's time to connect wires. Before making any connections, verify that the power is off. Connect the AC side wires meter input to the grid connectors on the meter through the circuit breakers. To connect the CTs to a meter, connect the CT wires to the 3 2-pin terminals. Ensure that the black and white wires align with the black and white dots shown on the meter. Insert the terminals block into the socket on the meter, making sure it is fully seated. To connect the RS-485. 1. Insert the RS-485 wires from the meter through the communication gland of the inverter. 2. Pull out the RS-485 terminal block, insert the wires into G, A and B and tighten the terminal block screws. 3. Push the RS-485 terminal block firmly back. Meter configuration. To configure the meter, from the commissioning screen, select Site Communication. RS-4851. Protocol. Modbus multi-device. Continue by configuring the meter function. Return to the RS-485-1 menu and select Add Modbus device. The identified meter is created and appears, select it. Select Meter 1. Select Meter Function. Select the required meter function, according to the type of meter installation, described below. Select Production, for meters installed at the inverter output, and reads the energy produced by the inverter. Select Export and Import, for meters installed at the grid connection point, for reading bidirectional flow of electricity. Select Consumption, for meters installed at the load consumption point, and reads the energy consumed by the site. Select Site Production, for meters installed at the master inverter output, and reads the energy produced by the entire site. Select External Production, for meters which are connected to a third-party inverter. And now, if needed, let's configure the device ID and the CT current rating. To configure the device ID from the RS485-1 meter 1 screen, select Device ID, and enter the device ID number. To configure the CT rating, from the RS485-1 meter 1 screen, select CT rating, and enter the CT rating, as shown, on the label of the current transformer. To verify the meter connection using Set App. 1. From the Set App main menu, select Status. 2. On the status page, scroll down to the Communication Status section. Check that one or more meters are connected to the RS485-1 or RS485-2 bus. Continue scrolling to the Meters section. If there is more than one meter function, there is a status subsection for each one. This example describes how to troubleshoot meter-related installation and performance issues. Communications failure. If NC not connected appears for a meter in the RS485-1 or RS485-2 subsections of the communication page, the meter is not communicating with the inverter. Or if the status in the meters section of the status page is COM error. These indications indicate connectivity failure between the inverter and the meter. Check the following: ID dip switch settings, termination dip switch settings, correct configuration by Set App, RS485 wiring to the inverter, commercial gateway, water damage or sealing problems, AC voltage of the meter with a voltmeter. The L1 line to neutral voltage should be 108/305 volts AC. Example 2, the energy value is not advancing. If the energy in MWH value displays a steady value even though the site is consuming power, check the following. If there are wiring loose connections at the inverter and the meter. The CT black and white cables are correctly connected to the CT connectors on the meter. The L1, L2 cable passes through the CT in the correct direction, according to the arrow on the inside of the CT. Check for water damage or sealing problems. Thank you for watching this unit about the SolarEdge energy meter with Modbus connection.